Hello everyone, welcome to my lecture series on financial mathematics. Now I am going to discuss the price versus yield relationship pertaining to a bond. So I have taken an example here and I have done some calculations using Excel. So as you can see here, let's assume there is a bond with a face value of 100 and an annual coupon rate of 5%, and the purchase date, let's take it as 17th May 2022, and the maturity date is exactly after 10 years time. It's 17th May 2032, which means this is a 10-year bond, and the payment frequency is 1, which means only annual payments, annual coupon payments. So as you can see in this table, I have calculated the bond price, this particular price of the price of this particular bond for different yields. So I will show you how you can calculate this using two methods. This is discounted in this section. You can see the discounted cash flow method, and here I have used the formula. So first I will show you how to get these prices using the discounted cash flow method. It's very easy. As you can see this formula, this let's take this time period, this time so starting from first year to 10 years, since this is a 10-year bond as per this example, and only one open payment is occurring. So these are the discounted factors and these are the present values. So the price of a bond is nothing but the present value of coupon payments plus the present value of this face value, which means the redemption value at the end of the 10th period, or as the final payment. You are getting this face value plus the coupon payment. So we have to discount both facts, right? So I will click on this formula so you can see. So in this formula, what we have done is we have discounted this first cash flow with the yield of 5% here, and the time period is 1. So this is the discounting factor. You can see this formula, right? So I will show this, and similarly for the second period, this is the discounting factor and the same yield applies. So this is the discounting factor, and we have to multiply that discounting factor by the coupon rate and the face value to get the coupon payment. In this example, 100 into 5% is what? Only 5. So coupon payment is 5. So similarly, I have done this calculation. So you can see that. So the ultimately the sum of these values, sum of these cash flows gives us the price of the bond. Where and the other thing I would like to highlight is that at the end of the period, you can see this. In addition to this coupon plus the face value, the coupon payment plus the face value, the redemption value, we have to discount to get the present value. So that is in this formula. You can see I have incorporated this face value also to the calculation. Another thing you can see, if the coupon rate is same as the yield, then what about the price? It's none other than the face value, or the redemption value and the face value or the price all is similar. So if the coupon rate and the yield is 5%, the face value is same as the price of the bond. So we will discuss this. So we will verify this with this table values. So I will change this yield to 0. Let's see what is happening. So if I change this value to 0, which means this discounting factor becomes 1, right? So you can see from this formula, this discounting factor becomes 1, and only we are left with this 5% coupons plus the 105 at the end of the 10th period, where the price of the bond becomes 150. This is the first scenario. Then Afterwards, if we change this value to 5%, let's change it to 5%. Then you are left with this 100, as I explained previously. And then what about 10%? Then it becomes, the price drops to 69.28. At the yield of 10%, it becomes 69.28. Likewise, if we take somewhere around here at the rate yield of 50%, let's take the yield of 50%. Okay, it's 11.56. So we can verify this. So as you can see, once the yields are getting higher, or yields are increasing incrementally, the price of the bonds getting decreased. So this yield and the price and the yield has an inverse relationship. So I have done this using discount factor, taking these cash flows one by one. And here I have used the formula. There is an inbuilt formula in Microsoft Excel where you can directly plug in the numbers and get the bond prices. So I will explain this also. This is the formula. You have to type equal price, the first one, C5. What is C5? The purchase date. First you have to input the purchase date, and then C6, which means maturity date. And then you have to take the annual coupon rate, which is 5% for this example. And then F4, which is the yield. Yield, I have selected this 0 since to this, according to this scenario, it is 0. So then you have to take the face value, the redemption value of the bond, and then you have to take the payment frequency, which means which one means annual coupon payments. So there are different, there might be different coupon payments. So I think, I mean, some bonds pay two coupons, semi-annual coupons, which means you have to take two as the payment frequency. Some pay quarterly coupon, so you can take 4 as the coupon payment. And finally, this one is the basis of calculation. So one means it's a actual basis. You calculate this bond price. So that's all. So you have to plug, after you plug in that numbers, you can get this value for the respective yields. So I have done the calculation. So in according to this scenario, yield is 15%. You can see I15, right? I4. I4 is 15%. Likewise, I have calculated up to 55% of yield. So this is the relationship. So bond price has an inverse relationship with yield rates. So if I change the coupon rate, this initial annual coupon rate is 5%. So if I change it to somewhere around 8%, let's see what is happening, right? So I changed this to 8%, and you can see there is a shift, upward shift in this curve, this bond prices, which means the higher the coupon, the price gets increased, which means there is a direct relationship between bond price and the coupon rate. So if we come back to the original scenario where it's 5%, now it's here. And if we reduce this coupon rate to somewhere around 2%, I'm changing the value here. Let's see what is happening. If I change it to 2, the curve gets shifted downwards, which means, yeah, again we can verify that there is a direct relationship between the coupon rate and the bond price. So that is the basic idea. So why all this happen is that we can mathematically explain based on the formula, this bond pricing formula, why this is happening. So I will take you through that formula, and let's discuss how we can get the duration of a bond, which is a very good sensitivity measure, and the convexity of a bond. So first I will explain how to derive this by the bond pricing formula. So how you calculate this bond price manually using mathematics? So this is the formula, price of a bond. So I will write down the formula here. So price is nothing else but this present value of coupon payments plus the present value of the face value of the bond. So if we take an example, a simple example, let's take a 10-year bond where then coupon payments occur. If we take the coupon payment as C, there are 10 coupons at the end of this period, you are getting this redemption value also. So to find this, find the price of the bond, we have to discount all the cash flows to this beginning point. So we have highlighted this. So this is the price of the bond. Present value of all coupon payments plus present value of the redemption value or the face value. So this gives the price of the bond. So we can write this formula like this: price of the bond equals for this first payment, we can write it as coupon. We have to discount it. Let's take the rate or the yield as I by one period. You have to discount this to this point. And similarly for the second payment, coupon has to be discounted twice. So from here to here. So similarly for let's take a general case where if there are n payments, not this 10 periods, like if we take this as n number of periods, for the nth payment, you have to write it like this. And we cannot omit this part. This part has to be incorporated. So I will write this also. The redemption value, the face value also has to be discounted to the beginning point. For this n period, in periods, you have to discount it by n times. So this is the basic formula. So as you observed from the previous example, that bar chart, the price of a bond against yield of a bond as an inverse relationship like this. So this gives this relationship, this formula. So how can we get a sensitivity, or like how responsive is this curve to the changes in this yield? So we have to find it out. So if we are doing some calculations, you can find the sensitivity measure. So we can take the first derivative of this curve to find the sensitivity. So I can write this formula as this to find the first derivative. So I can rewrite this as 1 plus I minus 1 plus C 1 plus I into the power negative 2, and similarly up until nth payment 1 plus I to the minus n, and finally f into 1 plus I to the minus n. These factors are similar since this is the final payment, this one, right? So if we continue and move on, so I can find, I will rewrite this, I will take this coupon payment part, since this is a constant which appears until this point, so I will take this C out as a common factor, and then we are left with what? 1 plus I to the minus 1 plus 1 plus I to the minus 2 as the second payment, and until 8th payment it's 1 plus I to the minus n plus this f into 1 plus, sorry, I will erase that. So okay, 1 plus I to the minus n power. So this is the formula. So now I am going to get the first derivative here, dp over di, since we differentiate to get the first derivative with respect to I to find the sensitivity or the rate of change with respect to yield of this curve. So we can write it like this. Since this is a constant, we can take the derivative of these factors, right? So it's like d over di 1 plus I to the minus 1. Similarly, for the second payment, it's d over di 1 plus I to the power minus 2. And for the nth payment, d over di 1 plus I to the power minus n. And we have to differentiate this also. This f is a constant, we can take it out, and it's d over di 1 plus I to the power minus n, right? So this is the formula which we are getting. So I will further do the differentiation part. So it's dp over di, then we can differentiate. After differentiating, what we are left with is this minus 1 comes in front, minus 1 multiplied by 1 plus I to the power negative 2, right? Then for the second payment, this minus 2 comes in front after differentiation. Then it becomes negative 2 into 1 plus I to the power minus 2 minus 1 minus 3. Here also minus 1 minus 1 minus 2. Likewise. So until the eighth payment, this until the nth payment, this n minus n comes in front, and then we are left with 1 plus I to the power minus n minus 1. So this is how it is done. So for this f also, this minus n, we can straight away write this as we can straight away take this negative factor here, this negative for the minus n here, this comes in front, and we have to multiply it by f, and 1 plus I minus n minus 1, similar as this one. So this is the first derivative of this expression. So we can further simplify this. So I'm going to take this minus factor out, and I'm going to take 1 plus out, 1 plus I also, 1 plus I factor also out. So if we can write this, we can write it like this: negative factor I'm taking out from this bracket, and I'm taking 1 plus I, 1 plus I also out. Then what we are left with is, since we have taken this negative factor, one positive 1 is here, and 1 plus I to the power not minus 2, only minus 1, right? Since we multiply this part with this part, we are getting minus 2. So now we are left with only minus 1. So similarly, this, since this negative factor is taken now, now this becomes positive. 2 into 1 plus I to the power not negative 3, it's negative 2. Similarly, plus this n is there. Since you have taken the negative factor out, we are left with positive n, 1 plus I, not minus n minus 1, it's only minus n. And for this part also, I'm going to do the same thing. Negative factor is here, n is here, and if also take like this, and I am taking 1 plus I out, and we are left with 1 plus I only minus n. So further we can simplify this. So I will take this down. So dp over di, we take, now I am taking to get the common factor for both of these components, taking a common factor, only 1 plus I am taking, right? So what we are left inside is coupon payment, and this is a series of payments. So we can write this as a summation, right? So with the sigma notation, this -1, -2, minus n are the time period. So we can write it as t starting from 1 to n. This t represents this the time frame or the timeline. 1, -1, -2, 3, likewise. T starting from 1 to n, then we can write this as this 1, 2, 3 up to n, the time as t into the coupon payment is here. We took this here, then we can write it as 1 over 1 plus I to the power t. So this is the formula, this part, this coupon payment part. So similarly, we can write it for this final payment or the face value or the redemption value part also. So we can add this, since we have taken this negative 1 plus I here, so we are left with what? N times f, the face value, and 1 plus I to the power n. So this is the formula for the modified duration. We call it modified duration, and as a standard, what we are doing is we are taking this negative factor away and we are rewriting this. I will rewrite this, the exact modified duration formula, so it's like a weighted average. So modified duration is duration. We are getting the modified duration as, we take this negative out as this, and we write this modified duration as 1 over 1 plus I, which is the yield, multiplied by, I'm taking this coupon payment out here, C sigma t starting from 1 to n, t times this one, t divided by 1 plus I to the power t, and we can add this part also, n multiplied by f divided by 1 plus I to the power n. This is the final payment, only applicable for the final payment or the end of the period. We can use n straight away. Yes, other t's, these are getting changed. For the first payment, t is 1, so the second payment, t is 2, likewise those are getting changed. For the modified duration, in addition to this first derivative, we are dividing this whole thing by, whole statement by the price of the bond, price, or else we can write it as P. So this is the modified duration formula which we can calculate or rather derive from this differentiation. So in addition to modified duration, there is a duration or standard approach called Macaulay duration. So Macaulay duration is very similar to modified duration. In this Macaulay duration, D, or some people call it DMAC or whatever, macular duration. So we take this part out, we omit this part. So the macular duration is nothing but coupon payment into this t starting from 1 to n, t over 1 plus I to the power t. I will erase this. So we have to write this part also. Then we have to write this n times the redemption value, the face value, divided by 1 plus I to the power n. This whole thing we have to divide by the price of the bond. So this is the macular duration. So you don't need to have this I mean, you don't have to remember all these formulas, right? You can derive, but with the time constraints and all, when you prepare for the exam, it's better to apply this formula straight away. But this is how we can derive these formula. This is the macular duration in this. And what is the relationship between the macular duration and the modified duration? So it's let's say modified duration is this macular duration divided by this 1 plus I component. So 1 plus I. This is the relationship between the macular duration and the bond modified duration. So if this is for the annual coupons, if it is semi-annual coupons, we can write it as modified mod D. You can shorten this as modified duration is nothing but MACD, macular duration, plus 1 plus I divided by N. This N stands for the payment frequency. Or else you can use another term. So if you are getting confused, then you can use as, let's say, I will write use a different letter. This as, let's say, K, whatever. So this is the relationship between modified duration and the macular duration. So when you get this duration, this is like a weighted average. So you can get an idea how sensitive is a bond for the yield rates. So this is the basic calculation, how to derive this macular duration, the modified duration. So in my coming lectures, I will discuss how to get the convexity of this yield curve. So another measure where we can find the convexity or the curvature of the yield curve, price and the yield of a bond relationship. So how this curve is the curvature of this yield curve. So thank you very much. I will discuss further this about the convexity, and so let's meet again. Thank you.